Hello, I'd now like to show you how we can go from one type of return to another type of return. So on this problem number one, we assume the HPR, the holding period return, is equal to 20%. We're given the information that the investment horizon involves n equals 3 periods, and we're asked to determine what the geometric mean periodic return would be. Now, the key to these problems is to always get to the price relative, E over B, because that's the common factor for all of our different ways of quantifying returns. So we know the HPR, so we put down the equation for HPR. HPR is equal to the price relative less 1. HPR is 20%, so we say 0.2 equals the price relative minus 1. Therefore, we know the price relative equals 1.2. Since we're solving for the geometric mean periodic return, we then just put the equation for the GMPR. It's the nth root of the price relative less 1. And we plug in what we know, the price relative, 1.2. We also know n is 3. So therefore, we know that the geometric mean periodic return is equal to the third root of 1.2 less 1. And when we do that, we get a GMPR value of 0.0626. And therefore, it's equal to 6.265857%. And that's our first example. Now, let's look at a second example. In this example, we're given the geometric mean periodic return. It's assumed to be 10%, and the number of periods in the investment horizon is assumed to be 15, and we're asked to determine what the CCR is. So we start off with the definition of the geometric mean periodic return. It's the price relative raised to the 1 over n power minus 1. It's the nth root of the price relative less 1. So we know GMPR is equal to 10%, so we say 0.1 equals, well, we know n is 15, the 15th root of the price relative minus 1. We add 1 to both sides, and we see 1.1 equals the 15th root of the price relative. And now we raise both sides to the 15th power, and we get 1.1 to the 15th power equals the price relative. And calculating 1.1 to the 15th power, we get 4.1772 is our price relative. While we're solving for the continuously compounded return, the definition for the continuously compounded return is that it's the natural log of the price relative. And therefore, the CCR is the natural log of 4.1772. We take the natural log of 4.1772, and we get the value for the CCR at 1.4296, which stated as a percentage is 142.96%. Again, remember the key to going from one given return statistic to another is to get to the price relative, because that's the common factor in all of our quantifications of return. Also keep in mind that the price relative is E over B. And that's what we need, the value of the price relative. Keep in mind that there are an infinite number of combinations of E and B that would give us the same price relative. So all we need is the price relative, E over B. That's all. Thanks for watching.